let's look at some linear equations. Now, solving linear equations is one of the first techniques you learn in algebra. So we're going to take a look at these techniques right from the very basic examples that you see here on to the more difficult examples like you see here. So starting off, what is a linear equation and how do we work through them? So let's take question 1 here. 3x is equals to 12. Now what is this asking me? This is basically telling me 3 times some number that we don't know is 12. 3 times what is 12? Now most of you guys watching this will realize, well, 3 times 4 is 12, so therefore x must equals 4. And that would be correct. However, there's a technique that we need to use in order to understand the balance of linear equations. So we're going to learn these techniques and that will help us when the equations get more challenging. So let's have a look at the exact same question. 3x is equals to 12. Now the idea with a linear equation is I want to solve for x. I want to have x on its own. So how do I go from 3x to x? If I have 3x and I want to get x, well, I will divide by 3. To go from 3x to x, you divide by 3. Now, we have to understand how equations work. Equations are about a balance. The left-hand side equals the right-hand side. So we always have to have a balance. The left and the right-hand side have to balance. So if I do something to the left-hand side, I must do the exact same thing to the right-hand side. So in this case, I had 3x equals 12. I decided because I have 3x and I only want x that I will divide by 3. So if I divide the left-hand side by 3, I have to also divide the right-hand side by 3 to maintain the balance of the equation. So then we can see 3x divided by 3 will just leave me with x equals, and 12 divided by 3 is 4. Okay, so that's the technique we're going to do. We're going to divide and we're going to do the same thing to each side in order to maintain the balance. Let's have a look at a couple of other examples. Okay, 5x is equals to 30. So I want to go from 5x to x, so I'm going to divide by 5. If I divide the left-hand side by 5, I have to divide the right-hand side by 5 to maintain the balance. So then my next line will be x is equals to 30 divided by 5, 6. Let's have a look at another example. Let's say I have 3x is equals to minus 21. So same again, I want to go from 3x to x, so therefore I'm going to divide by 3. If I divide the left-hand side by 3, I have to divide the right-hand side by 3 to maintain the balance. 3x divided by 3 is simply x equals, and minus 21 divided by 3 will be minus 7. Minus 21 divided by 3 is minus 7. Let's have a look at one more example for you guys. So let's say I have minus 4x is equals to minus 32. Same again, I want to go from minus 4x to x, so I'm going to divide by minus 4. If I divide the left-hand side by minus 4, I have to divide the right-hand side by minus 4. So therefore, minus 4x divided by minus 4 is x is equals to, and minus 32 divided by minus 4 is 8. That's a plus 8, because remember, minus by minus is a plus. Okay. So that is a brief look at an introduction to linear equations. Now remember, the idea is you have to maintain the balance of the equation. So whatever operation you do to the left-hand side, we do the same operation to the right-hand side. And the first operation we looked at was dividing to isolate x. If we have 3x and we want x, we divide by 3. Our other example, if we have 5x and we're interested in x, we divide by 5. If I have minus 4x, I divide by minus 4. So our first operation was some simple division in order to isolate x. Let's step it up to level 2. But before we do that, my advice to you guys is to practice some of these questions on level 1. Make sure you've got the idea of the basics before you move on to level 2. So let's have a look at the second level of these linear equations. So let's have a look at question 1 here. 2x plus 5 is equals to 17. So I've got 2x plus 5 is equals to 17. 2x plus 5 is equals to 17. Now we know, because it's a linear equation, we want to isolate x. I want to get x on its own. But before I can get x on its own, we're going to isolate 2x. So right now we've got a 2x plus 5. So to go from 2x plus 5 to simply having 2x, well, I must subtract 5. All right, I must subtract 5. Now, if I subtract 5 from the left-hand side, remember, to maintain the balance, you also have to subtract 5 from the right-hand side. So my next line will be 2x, then plus 5 and minus 5 will cancel each other out, equals, and then 17 minus 5 is 12. So then if 2x equals 12, then dividing both sides by 2, we're going to get x is equals to 6. Let's have a look at another couple of examples here. So on the left-hand side of the page here, 4x plus 3 is equals to 55. Okay, so first step, I got to get 4x on its own. So I have to get rid of this 3. So I'm going to subtract 3 from the left-hand side. Therefore, I have to subtract 3 from the right-hand side. So my next line will be 4x, the plus 3 and the minus 3 cancel each other out, equals, and then 55 minus 3 is 52. Then to go from 4x to x, I need to divide by 4, dividing the left-hand side by 4, also dividing the right-hand side by 4, and I will get x is equals to 13. Okay, have a look at another example on the right here. 8x minus 14 equals 50. 8x minus 14 equals 50. So the first thing I have to do is deal with this minus 14. So to get rid of the minus 14, I'm going to add 14 to the left, therefore remembering to add 14 to the right. So my next line will be 8x, then once again the minus 14 and the plus 14 will cancel each other out, equals, and 50 plus 14 is 64. So if 8x equals 64, to go from 8x to x, we'll divide by 8. So x will equal 64 divided by 8, 8. One more example for you guys. 10x plus 19 equals minus 41. So the first thing I'm going to do is deal with this plus 19. So by dealing with this plus 19, we're going to subtract 19 from the left, therefore also subtracting 19 from the right. So my next line will be 10x, the plus 19 and the minus 19 will cancel each other out, equals, and minus 41 minus 19 is minus 60. So then dividing both sides by 10 to get x on its own, and we will get x is equals to minus 60 divided by 10 is minus 6. Okay, I want to examine these linear equations in a little bit more detail and show you the different ways it can be represented. Maybe you think your teacher in school does it slightly differently, and I just want to show you how it really is exactly the same thing. So looking at this question here, 2x plus 5 equals 17. So I'm just going to write this out with a bit more space. 2x plus 5 equals 17. Now we know that the next step is to subtract 5 from each side. So we're going to subtract 5 from the left-hand side, therefore also subtracting 5 from the right-hand side. So what would my next line be? My next line would be 2x. Now the plus 5 and the minus 5 would cancel each other out. And I'm going to say equals 17 minus 5. I'm not going to do the subtraction just yet, because I want you to look at the first line here and look at the third line here. So if we ignore the second line for a second and we just go straight from the first line to the third line, what it looks like has happened is the plus 5 has moved to the other side of the equals to sign and become a minus 5. A lot of teachers teach it that way, and it's important that you understand that that's really just a result of subtracting 5 from both sides. So the point that I'm trying to make is, you might see the question done like this: 2x plus 5 is equals to 17. A lot of people like to take a shortcut and skip this second line. And this is okay as long as you're not making any mistakes. So we can look at it like this: 2x plus 5 equals 17. We'll bring the 5 over to the other side and remember to change it from a plus to a minus, because that's what happened here. So my next line, I can just say 2x is equals to 17 minus 5. 2x is equals to 12, then dividing both sides by 2, x is equals to 6. So A lot of times we look at it as if we're bringing the value over to the other side and changing the sign, but that's really just a shortcut, and it's a result, as you can see here, of subtracting 5 from both sides. Let me show you one more example. So 4x minus 10 equals 14. I'm going to write this out again. 4x minus 10 equals 14. So once again, we know the first step is to add 10 to cancel the minus 10. If you add 10 to the left, we have to add 10 to the right. So my next line would be 4x. The minus 10 and the plus 10 would cancel. And I'm just going to leave it as equals 14 plus 10. Now, once again, looking at the first line and looking at the third line, it's as if the minus 10 went from the left-hand side to the right-hand side and changed from a minus 10 to a plus 10 as it went over the equals sign. So once again, that's just a result of adding 10 to both sides. But as people get better at linear equations, we generally skip from the first line to the third line. So it is okay to do that. So 4x minus 10 equals 14. Next line we can simply say 4x is equals to 14 plus 10. So we're just skipping this line. And then 4x is equals to 24. Dividing both sides by 4, x will equal to 6. So while it's important to understand that when working in linear equations, it's all about maintaining the balance between the left-hand side and the right-hand side. So whatever you do to the left, you do to the right. So if you add 10 to the left, you add 10 to the right. If you divide the left-hand side by 4, you divide the right-hand side by 4. But as I said, a lot of people will start to skip this second line and go straight from the first line to the third line, making it appear as the number crossed the equal to sign and change from a minus to a plus or a plus to a minus. So whichever way you like to do it is up to you. One more example. So we've already done this question, 10x plus 19 equals minus 41. We can see it here where we really kept an eye on the balance, subtracting 19 from both sides and dividing both sides by 10. Now we'll do it the slightly quicker way, where we'll just say 10x is equals to minus 41 minus 19. 10x is equals to minus 60. Then dividing both sides by 10, x is equals to minus 6. So that is our introduction to linear equations. My advice to you now is to practice these questions on level 1. When you're happy with those, practice some of the ones we just talked about, the level 2 questions. We have more difficult questions to look at. I'll look through those in the next video. And between now and then, as I said, you can practice your questions, check your solutions online. And for access to questions, solutions, graded quizzes, and more, visit www.linearmaths.com.